Hello friends, I hope you all are well. In the previous video, we have discussed about the different type of logic gates that are used in the digital communication. So moving on from that, in today's lecture, in today's video, we will discuss about the number system, which are the backbone of any digital communication. So without wasting any time, let's get our today's video started. When we talk about transmitting any kind of information, especially in we have talked about in digital communication, so how we can represent that particular form of information? Either we represent in terms of zeros and ones, which any device can understand, or we can present that information in more human friendly way. So due to that, we have a number system for that. It is known as number system. So what this number system is? A number system is a backbone of any digital communication where a certain type of information can be represented, it can be analyzed, or it can be transmitted in any form. So because of that, we have four type of number system. That is, first one is we have a decimal number system. Second, we have binary number system. Third, we have octal number system. And fourth, we have hexadecimal number system. Okay, these are the four main type of number system which we are going to study in today's video. So there are also other type of miscellaneous number system, like type which have base 3 number system, which have base 5 number system, and etc. much more. So but we are going to discuss about these four main type of number system, and they have a certain called base, which how you can represent them. So a number system, a number system like a decimal number system, it has a base of 10 because it ranges from, it can be represented from 0 to 9, any number between from 0 to 9. Binary number system has a base of 2 because it has only two values, 0 and 1. Octal has a base of 8, from it can present from 0 to 7. 0 to 7. And hexadecimal has a base of 16 because it can be present in by from 0 to 9 and then A to F. These are the symbols you can, like from 0 to 9, then A to F represent from 10 to 15. Okay, so this is how you can represent this number system. So each number system have a unique purpose in digital communication. For example, this is if we talk about binary number system. So every device we use that are connected to internet, that can wirelessly, like your laptops, your mobile phones, what they understand? They understand binary number system. They are in actually behind those. They are actually programmed in binary languages, or like you can say that if we type a code, we type in English, but the system doesn't understand English. So we convert that English language that we are familiar with into machine language. Okay, that are called compilers. So these number systems are essential. They are for a low level operation for digital circuits. Whereas if we talk about more human friendly way, then we have the digital number system, octal number system, and hexadecimal number system, which are used for the interpretation and manipulation of these binary data, which are used to represent in form of zeros and ones. So these ability to convert between these systems, like decimal to binary, binary to decimal, like and etc., is crucial. It plays very important role in encoding, error detection, and information storage and retrieval. So to we have to understand these number systems if we want to talk, if we have to move further in, if we have to move in digital communication, or you have to understand how digital communication works. So first of all, we will see how to convert a specific numbers into, how we can do conversion of specific numbers. Okay, like this to binary, binary to decimal, decimal to octal, octal to decimal. Means we have to how we can convert this. Okay, so first of all, let's check how we can convert decimal to binary and binary to decimal. Okay, now let us see how we can convert a decimal number system into other number system. So for that, first we have a decimal number system to binary number system. But first of all, if I have any number, especially in decimal form, but how can I recognize that it is a decimal number? So if suppose I have a number called 26, and I have to convert into binary, I simply give you a number 26. But how you can recognize that this is a number, is a decimal number, but not octal number or hexadecimal number? Because both in octal and hexadecimal, they are they are arranged with 0 to 7 and 0 to 9. So these two numbers are also present in that. So how you can recognize that this is a decimal number? For that, you have to look for its base. You have to look for its base. Decimal number system has a base of 10. So if it is written like this, or it's like a not brackets, it's simple 26 and 26 base 10, then it is a decimal. That number belongs to decimal number system and not other number system. So now we have this. How to convert this into this? For that, what you have to do, because we have to convert this into decimal number system, sorry, binary number system, who has a base of 2, what we have to do here is, we can do a method we are called repeated dividing. So what we have to do is, first of all, this place here 26 in this way. This you have to continuously dividing it by base 2 if you have to combine in binary number system. But if you are combining in other number system, then you have to divide it for that base. Okay, means what I am trying to say is, suppose I have to convert from decimal to ABC pyramid, ABC number system, whose base is suppose n. So I have to divide that decimal number by its another ABCD number system base for to get the values. So if we divide it by this, so let's divide. What will be 2 divided by 26? It will be 13. 0 remainder. Again, what will be 6? Remainder will be 1, because 2 into 6 16. Sorry, 12. 2 divided by 6 divided by 2 is 3. Remainder 0. Again 2. And now we have last step, that is 3 divided by 2 is 1. Remainder is 1. So you get this. So how you will know which one is LSB, which one is MSB, and how to write it? So you have to write in this way. This the last term which will be come after dividing it, that will be LSB, this will be LSB, and this will be MSB. Okay, so you have to go this way. So what will be my answer will be, if 26 I have to convert in binary, that will be 11010. 11010. 0. Okay, so this will be your how you can convert this 26 decimal number into binary decimal. I hope that is clear to you. Now let's try one more. Okay, let's try one more. Okay, you have a number. Let's try a bigger number. You have 52. Now you have to convert in binary. So how will we do it? Just pause the video and do it. Okay. So I hope you have done it. So how we'll do it? Same method. This is 52 divided by 2. What number comes to it? First will be 2. 26 0, because 26 multiplied by 2 is 52. Then we have 2 13, again 0 2 6 1 2, 3 into 2 is 6, it will be 0, and 3 divided by 2 is 1, it's 1. So this will be your answer. There will be 1 1 0 1 0 0. This will be your binary number for decimal number 52. Okay, and don't forget the base to write base. If you don't write the base, it will be considered to assume that it's belong to some other number system, ABCD number system. Okay, so this is how you convert any decimal number into another form. Okay, we will do some of the basic questions based on this in another. I will do another question. I'll start a series, a question series based on the digital communication. So let's move forward and see how you can do convert decimal number system into another, that is octal number system. Now let's see how we can convert any decimal number system into an octal number system. So we will use the similar method we have seen in when we have converted a decimal number system into binary number system. So for any number, any decimal number, suppose we have a decimal number system like 420, 426, this base 10, and we have to convert into octal number system who has a base 8. So now how we can do it? Similarly, by repeated division. So we have this 426 divided by 8. Okay, so when you divide it by it, what comes as a remainder? Let's see this 8 divided by 426. What we have, if you can first do 8 into 5, because 8 into 5 is 40 and 8 into 6 is 48. So it will be 5, remainder will be 2, and it's 26. So 26, what comes into mind? 8 into 5 is 40, 8 into 4 is 32, 8 into 3 is 24. So it's 3 and 2 will be your remainder. Okay, again divided by 8. So 8 into 7 is 56. 8 into 7 is 56, and 8 into 6 is 48. So 6, and what will for 53 minus 48? 53 minus 48, it will be 5. Okay, again 8, what will be it come? It will be, if we cannot divide it because it is less than the divisor, it will be 0. Okay, or you can just simply leave it. So what will be we will have this number. This is LSB, this is MSB. Then what will run? It's 650 652. So this is how you convert into octal number system. I hope you're all clear on this. So now let's try another one. Okay, let's try another one. Let's try another one, which is 30308. Okay, this is our decimal, and what will be octal. So just pause the video and do it. Okay, I hope you have all done it. So let's see 308 and 8 divided by 8. So 8 into 4 is 32, and we have it's 30, then it will be 3. 8 into 2 is 24, it's 68. Okay, 68. 3. 68. So 8 into 7 is 56, 8 into 8 is 64, 8 into 9 is 72. So 8 into 8 is 64, and it will be 4. 4 again. 8 into 5, 40. So it will be 4, and what will be it? It will be 4. Now you cannot further divide it, so we will leave it here. It will be 44444, and that is the octal number system, that is for 8308 for decimal number system. Okay, I hope you understood this much. Now let's move on to the last one, which is how to convert decimal number system into hexadecimal. We have seen how we can convert decimal number system into binary number system, and how we can convert decimal number system into octal number system. So now for the last part, that how we can convert it into hexadecimal number system. Both these number systems are almost same, because the decimal number system represents from 0 to 9, and this represents from 0 to 9 as well as A to F. Okay, so they are somewhat same but also different. So how we can convert it? Let's take a value. So we have 348 into 10. We have to convert in hexadecimal with base 60. So unlike the other two, same method, repetition, division. So here, if I divided this whole number 348 divided by 60. Okay, so this is a 2-digit number. So you for every division you have to remember your school time, that is tables. Okay, so 16 into 2 32, 16 into 3 48. Sorry, yes, 48. So 34 is smaller than 48. So 16 into 2, it will be 2 here. Then what's the remainder? 28. 16 into 2 not possible, then 16 into 1. Okay, so 16 into 1 16, so it will be 28 minus 16 is 12. 12 is the remainder. Again 16, but here 16 16 into 2, 16 into 1 16, 16 into 2 32. So 21 is smaller than 32, it will be 1, and it will be here 6. Sorry, it's not 6, 5. So now you cannot further divide it. So this will be your answer. 1, 5. But I cannot write 12 here. So this is, here comes the difference. You cannot write direct 12 here. It will become 4-digit number. For that, in special hexadecimal, we use symbols A, B, C, D, E, and F. They are represents. A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. We use these symbols in special hexadecimal because after 9 it becomes 2-digit number, and you cannot represent these 2 digits. Why? Because if I write here 12, then it becomes another percent related 1512. Okay, but this is not okay. This is that, but for a machine, for another number system, for especially for hexadecimal, we have to write this 12 in terms of these symbols. Okay, then it will be 15C, 15C base 60. So this is how you represent the hexadecimal. I hope you understood that this question. So let's do another one. What you can do? 526. Now, do it. Pause the video and do it. Okay. Now, using the same method, 526 divided by 16. 5 into 1, 16, 5 into 2, sorry, 16 into 1, 16, 16 into 2, 32, 16 into 3, 48, 16 into 4, 64. So 52 is less than 64, so it will be 348. And that leaves is 40, that leaves remainder as a 4, and 6 will be, so it's 46. Then it will come 16 into 2, 32. So this will be 32, and what will be left? 46 minus 32 will be 6. Okay? Wait a minute. 30, it remains 4, 46, 46 minus 32. Oh, yes. No, it's 14. It's 14. Then again, it's 2, it's 0. So this will be your final answer. 2, 0 and E. 20E. This will be your. Okay. So I hope you understood this much. So I'm stopping to this lecture here only. But in coming lectures, we will continue this further. We will see how you can convert bind into other number system, octal into another, and hexadecimal into another number system. Till then, if you are new to this video, please subscribe my channel and press the bell icon so that you won't miss any future videos. And please like this video, and because it gave me motivation to improve myself more. And please, if you have any suggestions, any doubts, write in the comment section. See you in the next video. Till then, thank you very much.